A slide is an inclined plane, meaning the surface is tilted. When the surface is tilted, an object will often slide down due to gravity. When my sister slides down the slide, gravity is a constant force pulling her down. The steeper the surface, the faster the object travels, and vice versa. Friction works against gravity and slows her down. Without friction, the person would slide down too fast. Too much friction, and the person would slide down too slow. The slide is 1.36 meters tall and 2.60 meters long. My sister, with all her winter gear on, has a mass of 35.6 kilograms, and it took her approximately 1.40 seconds to reach the bottom of the slide. Since she starts at rest, using one of the 5 kinematic equations, we can find that acceleration is 2.65 meters per second squared. With this information, we can complete the force diagram of my sister sliding down a slide. This is what the force diagram looks like. The friction force is going in the negative direction. The normal force is always perpendicular to the surface, even if the surface is tilted. However, the force of gravity is still perpendicular to the Earth. What happens is the force of gravity is resolved into 2 components, a force perpendicular to the tilt and a force parallel to the tilt. Last but not least, we can use sine law to determine theta, which is 31.5 degrees. Let's start with the force of gravity, which is the equation Fg equals mg, which equals 349 newtons. The parallel force of gravity can be determined with the equation Fg parallel equals mg sine theta. By subbing in our givens for the variables, Fg parallel equals 182 newtons. The perpendicular force of gravity can be determined with the equation Fg perpendicular equals mg cos theta. By subbing in our givens for the variables, Fg perpendicular equals 298 newtons. Since my sister isn't levitating, the normal force equals the force of gravity perpendicular, meaning normal force is also 298 newtons. The force of friction, however, takes an extra step. We need to determine the net force and then subtract the net force from the force of gravity parallel. The net force can be determined according to Newton's second law, where the acceleration of an object is directly proportional to its mass. This law can be summed up with the equation F equals ma, giving us 94.3 newtons as our net force. Subtracting 94.3 from 128 gives us 87.7 newtons as the friction force. Now that we have all the numbers figured out, we can start to connect slides to a few theories. The first is Newton's first law. Newton's first law states that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an unbalanced force. My sister is acted upon by an unbalanced force, continues in motion until she is stopped by an unbalanced force. Let's say my sister is too lazy to push herself off. When I push her, Newton's third law is demonstrated. When we make contact, there is an equal opposite force. The force my sister acts upon me and the force I act upon my sister. My friction force is equal to the force my sister acts on me. Therefore, I stay at rest. Since my force on my sister is greater than her friction force, she moves down the slide. When my sister is just sitting on top of the slide, she has gravitational potential energy. Gravitational potential energy is the energy stored in an object as a result of their height. These objects have the potential of falling. In my case, my sister has the potential to slide down. As she slides down, the energy is converted into kinetic energy. On top of the slide, kinetic energy is 0, and at the bottom, gravitational potential energy is 0. Slides were a big part of our childhood. Who knew they would play a role in physics as well?